Shaurya. We consider the battery through the capital R.
Okay.
Others comes on. So last class we are doing this thing, battery. Before going ahead, I think some of you are getting confused with that junction law. Let's do one question, a standard problem, and then we'll go ahead. This will be a good result to remember also. So let's say we have a resistor. Let's say this is NR, this is R, this is R, this is R, and this is NR. Find R equivalent. So I can keep N ka value anything I want. N is a constant. So I can keep 2R, 3R, anything. So that works out. Find the equivalent resistance of this guy. Let's do one question on this and then we'll go ahead with the normal stuff. Hope you remember the junction law. Start with any one point as 0 voltage. Find the voltage of the remaining points. If you can't find assume X and Y variables, then apply junction law at the nodes. Other scams on. Try 2-3 minutes, then we'll see. Try. How do you approach this? See, this is how you start now. Let this point be 0. Let this point be V. This will be 0. This will be V. Let this point be X and let this point be Y. So assume current I1, I2, and I3. So when you write the at junction X, I1 plus I2 plus I3 is 0. What?
सर वहां पे वो डायगोनल सिमेट्री तो एक वेरिएबल कम कर सकते हैं
कर लेना. And then x minus y. तो डायगोनल सिमेट्री में क्या आएगा बढ़िया?
नहीं, एक वेरिएबल कम हो जाएगा।
क्या हो जाएगा? What will you do exactly? Tell me that. This is 0. There is actually what you're saying, na? Right? Tha? But do you know what variable will reduce? I want to show you that, but won't necessarily get confused. So you can take for the y junction also. Keep it simple, na? It will be a little lengthy, but you can solve. I2 plus I2 plus I3 is 0. This thing will be y minus v by r, y minus x by r, plus y minus 0 by nr is equal to 0. There are two equations, two unknowns. Let's solve them. So first equation, r will cancel. You end up with x by n minus v by n plus x minus y plus x is equal to 0. So this would be x by n plus 2x minus y is v by n. Yeah, I'm right, I guess. This thing r will cancel again. This would be y minus v plus y minus x plus y by n is equal to 0. This guy would be 2y plus y by n minus x is equal to v. Am I right? Yeah, this is your equation 2. Have a look at this. I'm getting a more general, solution. So it will be useful in the exam if they give you 2r, you can find 3r, you can find. Now solve these two equations. I'll just show it on the next page. X plus n, 2x minus y is v by n. 2y plus y by n minus x is equal to v. So get x from here. 2y plus y by n minus v. Take this and substitute here. It's messed up, right? This would be 2y plus y by n minus v ka 1 by n plus 2 times 2y plus y by n minus y is v by n. Numbers are bad. Okay, I think you got the equation. Numbers are given, that will be more easy actually. General equation भी इतना अच्छा कुछ नहीं आ रहा है. If you solve this thing, you get 4y by n plus y by n square plus 4y minus y. So that will be 3y. That will be 2v by n. यहाँ से y का वैल्यू आएगा. That's pretty bad. Once you get y ka value, you can find the current in this branch. So y you get till get x also from there. So from this circuit, we can find the current in the brain branch. I is equal to I1 plus I1 dash, and R equivalent will be the voltage by I. I1 dash will be x minus v by R, and I1 dash will be y minus v by R. Actually, I think I can do something better. Wait, so if I add these two, I end up with x plus y minus 2v by R. I don't want x and y, I want x plus y. So can I do something about that? I don't want x and y, I want x plus y. Add these two. Then this will be x plus y by n plus 2 into x plus y minus x plus y is equal to v plus v by n. Perfect. X plus y common le lena, you end up with 1 by n plus 1. is v into 1 plus 1 by n. So I'm getting x plus y is equal to v. I put up somewhere. This is nr, na? That is nr. Shit. You can't do anything again. That would be x by n plus y. Sorry, you can't do anything.
I1 dash को equal करना I2.
कुछ नहीं कर सकते, मतलब इक्वेशन डाल के सॉल्व करना ही पड़ेगा. There's nothing we can. But this, please have a look at these equations. I think if you got this equation 1 and 2, job is done. Numbers are given, it will be more easy to solve. This is how you solve this circuit. Clear?
Sir,
Shaurya.
the one which you wrote with red should be dash na, मतलब I1 dash.
Actually there is a symmetry like Shaurya is saying. Let me show you that. That will be actually, I think that might give the answer faster.
I1 dash is equal to I3. No?
I1 dash is equal to I3 Q. I1 dash will be I3.
Okay.
But all got this how to do this kind of questions? HCM there is a one question if you observe. It was like this: 3R, R, and 3R. Unbalanced Wheatstone bridge. HCV there is a question like this. You couldn't solve it normally. This is the method you have to use to solve. It's an unbalanced Wheatstone bridge. This is an unbalanced Wheatstone. This is how you solve that question. So let me give you, like, how can you solve this faster? There is a point symmetry. Now the idea here is, think about it. If this is voltage V, this is 0. If this is X, whatever current flows in this branch, the same current will flow in this branch because symmetry. Can you see these two are symmetrical, these two are symmetrical? No? That means potential difference across these two should be equal to the potential difference across these two. So the potential difference is V minus X. So this is 0. So this point of potential is V minus X. Check. Basically, it is symmetrical about these two. These two are symmetrical. These two are symmetrical. The potential difference should be same between this guy and this guy. You can use this. Once you know that, actually, it becomes very easy to solve. You'll get X value pretty easily now. And please understand this thing. Ask me if you're confused. Why did I get X and V minus X? V minus X minus 0. The potential difference should be same because the current is same in the resistor. Is that making sense? So this is a diagonal symmetry. Diagonally, the currents and the resistors will be same. So if this was V, this was X, this is V minus X, this is 0. So if you apply junction law at X, we get X minus V by NR, X minus V minus X by R plus X by R is equal to 0. One equation we get X ka value, check. Isn't it? This symmetry saves you a lot of time. You get X ka value in one step. This will be X minus V by N plus X minus V plus X plus X. Bring all X to one side. That would be X into 3 plus 1 by n is equal to b into 1 plus n. That's your x ka value. This is a much faster way than the compared to previous one. If you use diagonal symmetry, you get it in one equation. Once you get x ka value, you can find the current in the branches and you can finish it off. Check it out. Do have a look at this. Let me give you one more like this. You just show me the voltages. Any doubts on this? Please ask me. These are all unbalanced Wheatstone bridges. You can't solve normally. Clear? Next one, just give me the voltages, okay, how they look. Solving, I will leave it to you. The working is. This is A, this is B. All resistors are identical. And you're connecting the battery between these 2 points. Can you look at the nodes? Iska voltage is how will you do? Junctional you have to solve. There is no way you'll get a symmetry here, but junctional will be high. Think for a minute or two how to solve this. It's a good one. Then I'll show you how to get the nodes. There's a symmetry, diagonal symmetry. Try. Everyone should try.
We can't disconnect the nodes. वो middle वाला.
Symmetry नहीं है ना? कैसा disconnect करोगे? To remove this, is this symmetrical? A and B are not mirror images.
But we can fold, no?
Fold कैसा करोगे?
Along that diagonal, मतलब.
ऐसा?
No.
Yes.
ऐसा? So you mean to say यहाँ पे 2 resistor, यहाँ पे ये किस पे लगी रहेगा?
Okay, ठीक है.
क्या symmetry दिख रहा है तुझे?
नहीं, ठीक.
See na, this is 1, 2, 3. Right? So there are 2 here. So this is this thing, no? It is not symmetrical. How will you fold it? Like this will fall on whom? It will fall on this guy.
नहीं, ठीक है.
नहीं ना, symmetry fold नहीं होगा वो. हाँ, this is a symmetry. See, if you have between A and B na, then this junction can be removed, right?
हाँ.
यहाँ पे ऐसा कुछ नहीं है.
The diagonal piece missing.
Yeah. Think.
So निकालना क्या है सर?
Find R equivalent. Or find the voltages at the nodes. Or find current in the branches. Anything. Find current in the branches. You can give this as a question only. Wait, 35. Think I'll get to 3 minutes. It's a good one. Did you guys figure out the notes? I'll give you 2-3 points. From there, you try to tell me what will be the other points. I'll start with this. This is 0. This is V. So this is 0. This is V. This is X. This is Y. It's not about other. Can you tell me what are these two? one thing is obvious. These two are not identical if you observe. What were the remaining two nodes?
X.
X kya hoga?
The
X
down
hoga.
one will be V minus Y.
Now see, this thing just to be discussed now. Current in this branch and current in this branch will be same. Make sense? See now, current is going this way, the current will go back here now. If you look at this point symmetry, everything along this point will be symmetrical now. You're getting it? Whatever happens here will happen here. Whatever happens here will happen here. Whatever happens here will happen here. Is that making sense? It's a point symmetry. Everything that happens here will happen here. So if you take this as X, so this potential difference and this potential difference should be same. If that is X, this will be V minus X. If this is Y, this should be V minus Y. The potential difference across this resistor and the potential difference across this resistor should be same. Potential difference across this resistor and the potential difference this resistor and this resistor should be same. Everything diagonally will look identical. Please check. Is this making sense? Because if you think about it, if you say this current is I, this current is I. If you say this is I1 and this is I2, then by symmetry, this is I2 and this is I1. The same way the current comes out, the same way current should leave also. If the current is same, then the potential difference is same because the resistor is same. So this potential difference is V minus X. So this is V minus X minus 0. Check. Once you got this, now you have to apply junction law and finish it off. You have to write two equations, right? One equation here, solve. Two equations, two unknowns, you'll get the answers. It's a good one. It's a complex question. Proper advanced question. But do check. Please ask me if I confuse you. All clear with this? Clear? Can I turn the page? Let's see one more. Do you remember that grid wala question? Infinite grid?
Yes.
What if you have an infinite hexagon grid? Honeycomb. Like this, it's an infinite honeycomb. Each segment is R. Find the resistance between this point A here and this point. Let's call this B and let's call this C. Find RAC. Means you're putting the battery between A and C. Find the resistance of the system. I hope you remember this grid ka question, how we did superposition. Send the current I, pull current I, see how the current is flowing, and then we solved it. But this time it's a hexagon. I can ask you RAB also, RAC also, but let's find RAC. Hexagonal grid. This goes on till infinity. Try. Finish up with this. So these are some of the little different, higher level circuits. I was just waiting for you to have a little practice. And then we'll go back to our batteries again. We are doing batteries in series and parallel stuff. How do you do this? If you remember that principle, I'll just give an idea in case you forgot. Send current I through this.
Q by 3, Q by 3, Q by 3.
इसमें I by 3, I by 3, I by 3 होगा. Then see, then send pull current I from here, then see the current in this branch here. Think. I'll give a minute or two. It's a good one. These are the kind of questions which are not difficult to solve, but they are difficult to figure out. If you know how to do, you can solve it in a minute. But if you're not getting an idea how to handle this, that's what makes this question tough. Any answers?
So 1 minute.
Yeah. Right. Reina, so far everything clear? Reina, you're there? Reina?
Yes, sir. I'm here.
Yeah. Anna, clear so far. Everyone should, try to resolve the circuit again. This is a good one. Huh? NR, you can simply take number 3R and try to solve. Take some numbers and try. But एक बार solve करो ये circuit. It is important. 2R by 3. Na Kavish. Not 2R by 3. I hope everyone finished that capacitors sheet which I sent. It's been sent almost 2 weeks back. And someone is saying we can't do the sheet because we have some other exam. Kavish. The sheet was sent almost 1 week, 10 days back. How to do this thing? See. First thing, let's say you send current I in this branch. How will the current split? I by 3, I by 3, I by 3. When this current I by 3 comes, what will be the current here? I by 6, I by 6. Agreed? That I by 3 will again split into 2 branches. Vice versa. If you pull this current, this is C. If you pull current I from here, then I by 3, I by 3, and I by 3 will go from here. And this branch will be I by 6, and this branch will be I by 6. Agreed? So if you take this junction A, B, and C, see, this is what happens. If you're sending current I, in this branch you get I by 3. In this branch you get I by 6. If you pull current I from here, in this branch you're getting I by 6, and in this branch you're getting I by 3. Isn't that what you're supposed to do? Superposition. If you send only current I, see what is the current in the branches. If you pull current I, see what is the current in the branches. If you do both of them together, the currents will add up. Rishi? Isn't that what we did in capacitors ka infinite grid? We assumed charge keep flowing to Q by 4, Q by 4. Then we said Q by 4, Q by 4. In the central branch, you get Q by 2, na? Isn't that the principle of superposition? If you send current I, find the current in the branches. If you pull current I, find the current in the branches. If you do both at the same time, you get the total current. So this current will be I by 2. This current will be I by 2. This is point A and this is point B. This is resistance R and this is resistance R. So we get VA minus VC will be IR by 2 plus IR by 2, which is nothing but IR. And we know R equivalent is the potential difference between the two terminals, VA minus VC by current, which is nothing but R. That's your answer. So across the resistance is R. Are you getting this? If you connect a battery between A and C, V, and the current is I, the R equivalent is given by V by I. Do check this out. It's a good one. Any doubts on this? Please ask me how I did this. Danya, clear with this? Vrinda, Labdi, Chirayu, Reena, Anamai, Dipanshu, Hasni, clear with this? Kavish, got this? Trisha, Kavya, perfect. All clear? Can I go ahead? Next one. So last time we did batteries in series and parallel. Next thing is mixed grouping. This is important. The result is more important. So what is this mixed grouping? Consider if you have n identical batteries. R and E are given and connected to an external resistance R. So the question is, I want to know how should I connect these batteries so that I get maximum current in the external resistance R. So we are trying to find, so this is like a question and a theory. How should they be connected? To get max current in R. So imagine like this. Let's say you have n batteries in series. And like this, you kept m branches. Example, let's say 10 batteries in series and 5 branches. This is connected to an external resistance R. Are you getting the diagram? Think about it logically. If I keep all of them in series, I'll get more EMF, but I'll get more resistance also. If I keep all in parallel, I'll get less resistance, but I'll get less voltage also. That means there's some fine balance. Somewhere you have to keep some in series and some in parallel. Now, since I don't know how to take it, I will assume n series and m branches. And total number of batteries is n. So capital N should be n into small m. Total number of batteries should be number of batteries in a series into the number of branches. So now my job is, if I can find the value of n and m, my job is done. Please have a look at this page. So this whole question is to find the value of small n and small m. How many batteries should I keep in parallel? How many batteries should I keep in series? Have a look at this. I'll show you how to do in the next page. So we will assume current I, current I, current I. So in this branch, current will be capital I, which is m times small I. So we are trying to maximize that capital I value. If each branch, since all the branches are identical, let them produce current I. So the current in the capital R will be small mi. Can you try? I'll give you a minute. Find the value of small n to get maximum current capital I. Try. I'll give you a minute. I showed you all the main stuff. Let's see how will you handle from here. I hope the question was clear. Naman? Anyone the question is not clear, please ask. Abhiksha, question is clear. Amu? Chalo, try. Find the value of small n for maximum capital I. Think. I'll give 2 minutes.
Sir, E is like that the potential difference now. Okay.
E is the EMF. Yeah. Try. How to find that capital I maximum value. You have to find the value of small n to get maximum I. Answer will come in terms of capital N, small r, and capital R. I will apply one Kirchhoff loop law from this thing. Overall like this, I'll go like this. If you write the equation there, you get how many batteries are there? N into E minus I into NR minus I into capital R is equal to 0, isn't it? There are N batteries in that branch and there are N resistors in that branch. So small I into NR, NE is equal to IR. And I also know I is equal to small mi, substitute here. So NE minus I by small m NR minus IR is equal to 0. So we get I is equal to NE by R plus NR by M divided by N. R by N plus R by small m. And I also know N is equal to small n into M. So we can get M is equal to N by N, substitute that here. Plus small r N by N. So this is the current as a function of number of batteries in series. Since you want maximum value, we need to minimize this for maximum I. What to do? Maximum minimum. So d by dn, remember n is the variable here, r by n plus rn by capital N. So if I differentiate this, you get minus r by n square plus r by n is equal to 0. We get n is equal to capital N small r by small r ka root. That's your answer review. You should definitely mark this up. I'll write on the next page. But pretty important result. A straightforward question in mains. They'll give you like this. There are 100 batteries. Capital R is 4 ohms. Small r is 2 ohms. Find the number of batteries in series and parallel. You get direct questions on this. But have a look at this, what I did, and then I'll write down this in the next page more clearly. Clear? So this is the result which you need to remember. So if the total number of batteries is n into m, the small n is given by n capital R by small r, and small m will be n small r by capital R. This is series. This is n branches. Example, let's say the total number of batteries are 100. Capital R is 8 ohms and small r is 2 ohms. Then the small n ka value will be root over 100 into 8 by 2. That gives you 20 batteries. So 20 batteries you should keep in series, and you have to keep 5 branches for maximum current. That's how they'll ask the question directly in the exam. Now, if they want to harass you for some reason, let's say n is 100, r is 27, and small r is 3, then we get root over 100. That will be 30. The problem ye hai, if you put 30 in series, you won't get proper branches. So for 100 batteries now, if you take the combination series into branches, you can take 100 batteries in series, 1 branch. You can take 50 in series, 2 branches. 25 in series, 4 branches. 20 in series, 5 branches. 10 into 10, and so on. You can create all this. If you observe, for 30, the closest number is 25 by 4. So take the closest possibility. Mathematically, it is saying 30, but then you won't get a integer number of branches. So you take the closest possibility, 25 in series and 4 in parallel. Clear? If they want to play around a bit, this is how they can ask. But mostly mains or bits, they will stop here only. Do have a look at this. Quite an important result. Any doubts on this? Clear? All clear with this? Any doubts? Can I turn the page? Trisha, clear with this? Anamai, Amu, got this? Kavish, clear? Quite an important result. There, that is about combination of batteries. We saw batteries in series, batteries connected in reverse polarity. Then we saw parallel. Then we are seeing mixed grouping. The next thing is heat produced. So this is something which you learn in school also. If you have a resistor R carrying current I, the power produced in the resistor is given by V into I. This can be also written as I square R, or also can be written as V square by R. Be careful, V is not the voltage of the battery, V is the voltage across the resistor. The heat produced is given by power into time, which turns out to be, you can use VI dt, or you can use I square R dt. Mostly we use I square R dt or V square by R dt. If the battery voltage is constant, use V square. If current is constant, use I square. Have a look at this. That's about the heat produced. Clear? Let's see how they'll frame questions on this. Let's do an easy one. So we got a resistor here, 2 ohms, and let's say the current I here is Q is equal to T square minus 2T. T square minus T. Find the heat produced in 2 seconds. They didn't give you the current, they give you the charge. The charge flowing through the resistor is T square minus T. T is time and R is 2 ohms. Find the heat produced in 2 seconds. Get this. Easy one, just a matter of calculations. Chirayu, cams on. Others, do keep your cams on.
Eight.
How much? 8?
Yes.
इतना अच्छा नंबर आया क्या? इंटीग्रेट किया?
हाँ. I निकल.
So first I will be dq by dt, which will be 2t minus 1. The heat produced will be I square R dt from 0 to 2 seconds. This guy will be 2t minus 1 whole square. R is 2 into dt. 0 to 2. Bring the 2 outside and expand this bracket. 4t square minus 4t plus 1 into dt. This would be 2. That would be 4t cubed by 3 minus 4t square by 2 plus t. Limits will go from 0 to 2. This would be 2 cube will be 8, 4, 32 by 3. This guy would be minus 8 plus 2. This would be 32 by 3 minus 6. How much is that? 32 minus 18. 14 by 3. 28 by 3 joules. Check. Am I right? Anyone else got this? Do check it out. Yeah. Just a matter of one differentiation and one integration. Please check any doubts on this. But let me show how they'll actually ask you. This is still okay-ish types. Clear? Next one. Let's say we have a container of water. Two identical containers with water. So if you can produce heat produced, right, you can literally use entire thermodynamics again. You can produce heat and then you can use that to solve. In case one, what they did, you took two resistors and you kept them in series, R1, R2, and you connect a battery. And it took 40 minutes to boil the water. The same thing, you took two capacitors in, same two resistors, but this time in parallel. And then it took only 10 minutes to boil the water. Find R1 by R2. So you have two identical containers of water. Everything is same. Only thing is one is in series and one is in parallel. So when you took these two resistors R1 and R2 in series, it took 40 minutes. When you kept them in parallel, it took 10 minutes. Find the ratio of R1 by R2. Get this. It's a good one. This was asked in exam. Numbers are different though. Try. Anyone? What is the catch in this question?
Sir, one.
Yeah, one. Ratio is one. What is the catch in this thing? Since the water is same, shouldn't the amount of heat is same?
Yes.
So the heat produced in both the cases should be same. So the first case heat will be, it's a constant current. So V by V square by R1 plus R2. V square by R into time. Time will be 40 minutes. This is the heat. We are using the formula heat is equal to V square by R equivalent into time. And in the second case, heat will be voltage V square. Now, the reason why I'm using V square is because voltage is constant. R1, R2 by R1 plus R2 because both are in parallel. Into time is 10 minutes. Since heat is same, equate both the functions. You get V square by R1 plus R2 into 40 is V square by R1, R2 into R1 plus R2. V square will go off, 0 will cancel. You end up with 4R1 R2 is equal to R1 plus R2 whole square. This will be R1 minus R2 whole square is 0. Therefore, R1 is equal to R2. Check. Easy. Have a look at this. So the main catch in the question is the heat produced should be same. Clear. Next one. Any doubts on this? Labdi, got this thing? Harushi, Reina, clear? Vrinda, got this thing? Kavish, clear? Anamai, Dipanshu. Perfect. Hasni, clear now? Next one. We have a cylindrical resistor connected to a battery. Voltage V. This radius is A. This length is L. So rho is the resistivity. E is the quotient of emissivity, radiation. Surrounding temperature is Ts. So think about it. What will happen when the current starts flowing through the resistor? Heat will be produced. If the heat is produced, the entire resistor will get heated up. If the resistor is getting heated up, it will start emitting radiations. Isn't that how a bulb works? Once the temperature reaches a certain value, the bulb will becomes a visible light region. So for example, in a real life, if we are using a bulb, the temperature of the tungsten filament is 4000 degrees. The temperature of the filament is actually one of the hottest temperature on the earth. So once the temperature of a body reaches 4000 degrees, you start seeing visible light. So the question here is, find the temperature of the resistor in steady state. What is steady state? The amount of heat produced is equal to the amount of heat escaping. Heat transfer, radiation, and current electricity. Get this? Find temperature of the resistor in steady state. It's a good one, not a difficult, but it's a good one. Try. I hope the question was clear. Because the resistor is producing heat, the temperature will rise. Because the temperature rises, it will emit radiations. At one point, whatever power you're producing will be equal to the power that is radiating. At that instant, temperature will stop increasing. So find the temperature. That is the meaning of steady state. And this is what happens inside a bulb ka filament. You're sending current through a filament, the temperature will rise. Inside the bulb, it is a vacuum. Once the temperature of that filament reaches around 4000 degrees, you start getting the visible light. Remember this thing? Actually, I taught you this in heat transfer. I showed you something. Listen, I have a question. Listen, let's say you have a filament bulb ka. Okay? You're sending more and more current, it is getting heated up. As the temperature increases, can you tell me the color of the bulb?
Blue.
No. You have to tell me the color of the bulb. Single color nahi hai, Rishi. Current temperature is increasing continuously.
White.
First color is what?
Red, orange, yellow, white.
Orange, yellow, red.
First you will
Red
see
one.
red. Because initially when the temperature is low, what will happen? You will produce infrared, na? Can you tell me which concept is this?
Lambda m into T is
Wavelength.
Lambda m
wala?
into T is constant, na? Wien's displacement law. If the temperature is more, the wavelength is less. I hope you guys remember this thing. Wien's displacement law. So as the temperature rises, you start producing lower wavelengths. So the first wavelength you'll see is red. As the temperature increases, what will happen? You start getting red, blue, all colors now. If you get all colors, what will happen? It will become white. Green nahi dikhega, gods. You won't get a green bulb, blue bulb. If you're producing all wavelengths, it will become white. If you continue to increase temperature, what will happen? Then it will become blue. Because the wavelengths will start becoming ultraviolet. Ultraviolet you can't see.
Some type of stars are blue.
Which one?
The hottest type of stars are blue. They're not red. I
Yeah,
remember.
the hot stars are blue.
more light at every wavelength, at all the different colors, all the bottom of that's where
This
the
thing I showed you before.
different color of beta. So here the light bulb is barely
There, she's sending very less amount of current, so you can just see small red.
lit, and you can see that it's red-orange.
So basically, you're sending the current through that filament I square R that is becoming equal to the radiation emitted sigma E T power 4. That is the concept we are doing right now.
It's a very reddish color. This is almost exactly the color of Betelgeuse, one of the stars in the night sky. If I add more current so that the filament gets hotter and hotter and hotter, you can see that the red goes away and the color becomes dominated by yellow. If I continue on and I go past that point and I keep heating up the filament hotter and hotter and hotter, you can see it gets much, much brighter as it gets hotter, but then it also turns bluer as it gets hotter. Until here, this is as high as I can go with this particular light bulb, and you can see that the color of the light bulb.
This is how it looks if you increase the temperature, current more. The whole room will look dull because you can't see ultraviolet, but it is producing ultraviolet. It's producing lower wavelengths. So what you'll see is a blue colored filament there.
It's definitely bluish, and it's extreme.
So that means a blue flame is more hotter than yellow flame, kind of obvious. Next time, observe this thing. Go to your kitchen and switch on the stove. You'll observe when the flame comes out, it is blue initially, then it becomes yellow. Observe karke dekho. When you switch on the flame, because it is hotter on the starting point, it will be bluish. Once the flame goes little higher, it becomes yellowish.
Extremely bright at this high temperature. So this is something that you should look for when you look at stars in the.
So actually, blue stars are more hotter than red stars. So blue flame is more hotter than yellow flame or red flame. But for some reason, right, in all movies, cartoons, everywhere where they show red is like, very hot and all. Whereas in reality, the blue flame is more hotter. How do you do this thing?
Sir, V square A by rho L is equal to sigma E T B to power 4 minus 2.
Yeah, so basically the power produced by the resistor should be equal to the power emitted in the form of radiation. So power produced resistor will be V square by resistance. This will be sigma A E temperature of the body to the power of 4 minus temperature of the surrounding to the power of 4. Now be careful here. Resistance rho L by area, this A is cross-sectional area. In this formula, sigma A E T power 4, this area is surface area. Both the areas are not same. Most people cancel it out. This will be V square by rho length by pi A square. This is sigma. What is the surface area? The surface area of the sphere 2 pi A L plus 2 pi R square. Don't forget there are two disks also. You have to include even this surface area into E TV power 4 minus TS power 4. Numbers are bad, but yeah, that's it. Solve from here, you'll get TB. Check it out. Do have a look at this.
Sir,
Current electricity and heat transfer.
So is it necessary means if steady state is reached, so temperature of surrounding and body is equal?
If both are equal, heat क्यों जाएगा बाहर, शौर्य?
नहीं, net heat zero होगा ना, तो जाएगा पर उतना आपस अंदर भी आ जाएगा.
Yeah, that too will be zero. Net heat will be zero, or else temperature will keep rising.
Okay.
All clear with this? So there are one type of questions there. Now in this thing, there's another type of questions, bulbs. These are more important. Ever went to a shop and brought a bulb? Next time, observe that when you go to DMart or something, on the bulbs, it will be written something. Or if you see your adapter also, no, on the adapter, there will be written something, 110 volts, 220, 12 watts. Karke. So if you have a bulb here, this is what we call as the rated voltage. It will be written like this, 220 volt, 4 watts. What is the meaning of this? Now understand one thing. This does not mean it will work only at 220. What this means is, if we give 220 volt, then bulb produces 4 watts of power. That's it. That's what it means. It doesn't mean bulb will work only at 220 or something. So indirectly, what is being given, power is equal to V square by R. We can find the resistance of the bulb is V square by power. In real life, right, most of the time, if you see, everything in the house is 220 volt supply. So no one actually mentions that. If you go to the shop and ask him, give me a bulb, he'll ask you how many watts you want. It is understood that you're keeping across 220 volt. But let's say you buy a bulb in India and take it to US. US, what is the power supply? Anyone knows? 110 volts. So you took a bulb in India, which is 220 volt, 4 watts, and you connected to this a power supply in US, which is only 110 volt. Now, iska matlab ye nahi bulb won't work or something. Bulb will work. Now, what is the resistance of the bulb?
Dim.
It will become more dim. So 220 square by 4. So the power produced in the bulb will be V square by R, but the new voltage is 110 by 220 square by 4. This is 1 watt. So even though the rated voltage is 220 volt, because you gave 110, the bulb will produce only 1 watt. If you take a bulb from India and go to US, right, it will produce only 1/4 of the power. I hope you're getting it. You can take any bulb and keep to any voltage. Aisa nahi, 220 volt only you have to keep. But this is the meaning of rated voltage. If you keep across 220, you get 4. If I keep across something else, I'll get something else. But I can find resistance using this 220 square by 4. Do have a look at this. This is V rated. This idea is important. So same thing, if you bring a bulb from US to India and you keep it, it actually is 4 times brighter. Because that's rated for 110, but you're putting 220 here. And these bulbs and LED manufacturing companies, right? In the beginning, they used to make a bulbs like which will work for a long time. And then they realized if you make bulbs like that, people won't buy enough bulbs. So they introduced something called, there's a name for that. Planned failure. There's a more beautiful name for that, but we can simply call it as a planned failure. They make sure the bulb stops working after a certain point of time. This even Apple does that. When you buy a phone, like observe this thing, when you brought initially smartphones, right? Ever heard this thing? Your parents or friends will say, I used this smartphone for 4 years, 5 years. Kabhi suna? Now you see, every 2 years you have to change a phone. Nokia mobile alag hai. We're not talking about Nokia. So if you see, right, it's called, there's a name for that, right? Planned obsolescence, aisa kuch to tha word. So these companies design failure into the product. Best thing you'll observe, kabhi if you see a product with warranty, like Samsung or Apple or something, let's say they give a warranty for 1 year, works perfectly for 1 year, bloody 13th month it stops working. These companies actually do that. And they don't let you repair that. Maybe, it's a very small part in failure, okay? There might be a small shouldering part in the Apple phone. After 1-2 years, it might just get disconnected because of overheating. If you can connect that small part, it will start working again. But Apple won't let you open the phone. They'll put so many screws, they'll put so much, the covering on top of it. By the time you open the Apple phone, it breaks and the whole thing goes off. These companies do things like that. They wanted to buy a new one. So, and Apple also has a policy that you can't open it and all the warranty goes off. They'll scare you a lot. So Europe they passed a legislation. Like, you have to make your devices which should be able to repairable. Apple is fighting against it. Because if you see an Apple phone, right, they're just cheating you and we buy them like idiots. The phone will cost you barely like $250 or something. They sell it for $1,200, $1,000. They make huge profits. Corruption, matlab, yeah, welcome to business. Obviously, let's say if I'm making a profit of 10,000 crores, I'll just go to the politician and say, Dekho, I'll give you 100 crores funding. Just make sure the bill passes in the assembly. हो गया ना, they'll pass the bill. Or vice versa, I'll give you 100 crores and say, make sure the bill does not pass. Khareed lo, just buy some 20-30 MPs and let them make noise in the parliament. It'll get delayed by 1 year. Next year again delay. Keep on going the same story. Anyways, that's one thing. It's called planned obsolescence. I'm not getting the word, but planned failure. There's a better way to say. It started with the bulb. The bulb companies in US, they figured it out. They started making, if they make good bulbs and they work for 10 years, they don't have business. They started making bulbs which will fail in 1 year. And smartly they said warranty is 1 year. सबको क्या लगा था, अरे 1 year में bulb काम नहीं करेगा तो I can go back. But the point is after 1 year it fails. Planned obsolescence. Fine, I am not getting how to pronounce that. Okay. Most of our phones are laptops. Most of the things are designed that way nowadays. And you know what bullshit story they tell you? In 2 years, the technology will advance so much. It is better to implement, new components which are more energy efficient. In order to save the planet, we are making sure the device fails, which is energy inefficient, and you can use more energy efficient device. Bullshit energy efficient. 3 years back and now, what did you make the difference in the phone? 2 years back, the phone had 2 GB RAM. Now bloody you have 6 GB RAM. What are you going to do? You're building a supercomputer or what? Pehle phone had 5 megapixel. Now you have 200 megapixel. What the hell are you doing with your phone? मतलब phone में उसका कुछ purpose ही नहीं है. Other than phone calls, you're doing every nonsense. So yeah, it goes like that. Welcome to life. Now, let's see a question. So there's a company which came up with a slogan, uska naam kuch to tha, I forgot. It's a phone which you can build in pieces. They sell you parts. This entire phone is like a jigsaw puzzle. Huh? You
Yes,
don't
sir,
like
the camera is different and I have seen that.
Kab alag tha, uska naam kuch to tha, I don't remember. You don't like the camera, na? This part will be there. You can just remove this and put a new camera ka piece. You don't like the battery? There's a part like this. Remove this, put a new battery. You don't like the screen? Remove that, put a new screen. You don't like the processor? Remove it and put a new processor. Literally, the phone can be disassembled into parts. Whatever part you don't like, you can buy and put it. The phone is upgradable forever. There is a company like that. Search for it. You'll find they're coming up with this. Pata nahi, man. And anyways, tell me one thing. If you think about it, na, why do you use iPhone? For utility? Nah, to show off.
Sir,
Who actually use iPhone? बस भाई iPhone करके दिखाने के लिए. In that we don't even use 30% of the features also. Anyways, 220 volt for what? No, I don't like iPhones. So my first smartphone was iPhone. I went to the shop. I used a Nokia mobile. Okay, Nokia 2600 for 5.5 years. IIT ka 4 years, and after passing out, job pe 1.5 year. Finally, the poor Nokia mobile gave up. Not because it stopped working. In IIT, we used to use Nokia mobile as a weapon. Your friend is running away, take a Nokia mobile and throw it on him. That poor mobile used to hit him, used to fall down, split into 3-4 pieces. You can assemble and it starts working again. So it was misused to the highest extent. That poor thing. And finally, after 5.5 years, it gave up. So I went to a mobile store and I asked them, I need a phone. He said, sir, what is the budget? I said, 18,000. Big amount that time, 2011 ka baat tha. He said, sir, 18,000 mein aapko iPhone aayega. I said, I really don't care what phone it is. It should have Gmail. It should have internet. Bus. It should be able to make phone calls. I really don't care about anything else. He said, sir, take iPhone 3GS. That's my first phone. iPhone 3GS, I guess. Huh? iPhone 3 was my first phone. You guys use 14 and 15s, but yeah. I used that iPhone for 3 years. I hated it. You can't change the ringtone. You want to upload something, you have to upload from iTunes. You want to buy something, bloody buy apps. I don't know why. I never liked it. It had a good smooth interface.
There are many options for ringtones and everything.
Abhi na, but abhi, I think maybe after that first incident, right, I started hating it. And the other main problem, you know what? Think about it. Nokia mobile, it falls down. I don't care. This iPhone falls down, you used to get scared. Is the screen fine? Is the phone fine? So after a month, right, I started thinking, do I own the phone or the phone owns me? You're getting it. That's it. Then I decided I'll never buy a costly phone. After that, I bought Vivo phone. 12,000, cheap. It one day fell down from my hand. It broke into the screen broke. I didn't even feel bad. I just went in the evening and brought another Vivo phone, which worked for another 3 years. But the same thing happened with an iPhone, you will cry. So yeah. Anyways, that is the story of my iPhone. There we have two bulbs, 220 volt 4 watts and 220 volt 2 watts. So simple question will be, which bulb will be brighter? Find the ratio of power of the bulbs. Let's get this. Remember, 220 volt is the rated voltage. If you give 220, you get 4 watts, but you give 220 for both the bulbs together. Find the ratio of power of the bulbs. Let's get this. It's a good one. Keep going. Try. How do we do this? See, I'll just show you one. Let's see one more after this. So first thing, let's find the resistance of the bulb. So RA will be 220 square by 4. Let's call this R. RB will be 220 square by 2. Then this should be 2R. So I'll just read all the circuit. So this is R and this is 2R. Now see, I'm asking you ratio of the power. I really don't care how much is the current. Let the current be I. Because you want ratio, I will cancel. So power in the bulb A is to power in the bulb B will be I square into R is to I square into 2R. 1:2. The bulb B is 2 times better than bulb A. Check it out. So don't get confused with this rating. It does not produce 4. If you put 220, it will produce 4. Because you kept both the bulbs in series, the voltage will be less than 220 for both of them. The voltage will divide in the ratio of resistances. Have a look at this. So bulb B is brighter than bulb A by 2 times. Check it out. Trisha, you're asking a question like this only. Have a look at this. Let's see one more, a better one than this. Any doubts on this? How I did this, please ask. Since I'm asking for ratio, it doesn't matter what is the current. So just assume I and solve, that will get cancelled anyway. Dania, clear? Dipanshu, Kavya, clear?
So, but if we had to find I, then we have to go back to that R.
Calculate V by 3R current aa jayega. You can calculate. Clear? Let's see one more like this. This is bulb A, 220 volt 4 watts. This is bulb B, this is bulb C. Bulb B is again 220 volt 4 watts. Bulb C is 220 volt 2 watts. Find the ratio of power. Examine, they'll ask which bulb is the brightest or which bulb is the dim. but ratio power, that will give everything you want. Let's get this. It's a good one. Try. It's a good one. This is the kind of question you can expect in the exam. This week test is online, right? Mechanics. So do make sure to give. And properties of matter last week, some of you couldn't do well. I uploaded an additional practice paper. And remember, on the papers, it will be written practice paper. So that's a practice paper. Regular paper will be written as mains or advanced. So I did keep that heading also. Some of you are writing the practice papers and thinking you have given the exam. So be careful. Practice papers are online for a month till month end. So do make sure to give the mechanics ka paper. How do we do this?
Sir, junction ला लगाना है.
कुछ नहीं करना है अपना. First find the resistance of the bulbs. RA, RB will be 220 square by 4. Let's call this R. RC will be 220 square by 2. This will be 2R. Like I said, I'm not interested in the current exact value. I just want the ratio. So this is R, and this is 2R. So if you assume current I is flowing here, then current will split in the opposite resistances. More resistance, less current. So 2I by 3 and I by 3. So power in bulb A is to power in bulb B is to power in bulb C will be I square R is to 2I by 3 whole square R is to I by 3 whole square 2R. That is 1 is to 4 by 9 is to 2 by 9. 9 is to 4 is to 2. That's the ratio of power. Please check. This is how you handle this kind of questions. How much is the current? We don't know. We don't want also, because anyway it will get cancelled while you're taking ratio. So just assume a current I from the battery and split the current. I hope everyone got how I split the current here. Potential difference should be same. I1 R1 is equal to I2 R2. And once you get that, you are done. Do check it out. Asni, clear with this? Have a look at this, everyone. It's a good one.
So you took both of them in parallel.
They are in parallel.
Yes.
All clear with this? Any doubts on this? Please ask me. Chirayu, clear with this? Reena, got this? Trisha, clear, no? I hope you got the bulb models now. Abhiksha, clear? Perfect. Next thing. Combination of bulbs. What happens if you keep bulbs in series and parallel? So let's say if you take bulbs, and you connect across this, let the power of the bulb be P1, P2, Pn. So we know all of them are in series. So R equivalent will be R1 plus R2 plus so on till Rn. And we also know power is equal to V square by R, means power is proportional to 1 by R. We can write this thing as the total power 1 by P net is 1 by P1 plus 1 by P2 plus so on until 1 by Pn. So example, this is what it means, where V is the rated voltage here. For example, question they'll ask like this. They'll say there are two bulbs. $220. Let's say this bulb is 220 volt, 4 watts. This bulb is 220 volt, 2 watts. Means individually, if you connect them, you get 4 and 2. What happens if you connect them both in series?
4 by
1 by P net will be 1 by 4 plus 1 by 2, which is 3 by 4. Therefore, if you keep both the bulbs in series, you actually get only 4 by 3 watts. That is the meaning of this. So if you connect bulbs in series, the overall brightness actually reduces. Because the voltage across them will decrease, the power produced by them will decrease. You want more power, you should keep the bulbs in parallel. If you see till now, combinations, right? You know how many times it came, these kind of questions, combinations? First time you encountered where? Heat transfer, conduction. Then Poiseuille's equation, fluid mechanics, viscosity. Then springs, SHM. Then capacitors. Then current electricity. Sixth, bulbs. You saw this multiple places.
सर ऐसा कॉम्बिनेशन तो रे ऑप्टिक्स में भी था ना लेंस का
लेंस में भी था 1 by f1 plus 1 by f2 या बट उसमें सीरीज पैरेलल नहीं था ना.
हाँ हाँ
What about parallel? If we keep bulbs in parallel, P1, P2, Pn, the net power will be, just add them up, P1 plus P2 plus so on until Pn. So parallel is easy. The power just adds up. Series ka, this is a formula. Have a look at this. Clear?
so means it is same for both
What?
formula is same मतलब
What is same God? यहाँ पे 1 by P net is 1 by P1 plus 1 by P2. How does this look same?
नहीं वो मैंने R को P देख लिया अगर
All clear with this? Easy? Bulbs ka hai. This is another important one. Maximum power transfer theorem. This is there for HSC also. Not a big one. What this thing says is, if you have a battery with an internal resistance R and E, and if you connect an external resistance capital R, so we know I is equal to E by R plus R. Now understand here, R is constant. R is internal resistance, which is a constant. You can't change that. Capital R is a variable external resistance. You can keep any value you want for this external resistance. So the problem here is what, whenever you're using battery now, the power in the internal resistance which is I square into small r, this is actually wasted. You can't recover this. Because of this, the battery will get heated and you can't use this actually. The power which you're actually using is the external resistance, the power R, which is I square capital R. This could be your heater, this could be your fan, bulb, anything. So this would be E square into R by R plus R whole square. So for different values of capital R, you get different powers. We need to maximize this. So I want to find out what is the value of capital R so that I get maximum power in the bulb. That is called maximum power transfer theorem. we need to maximize this function. So maximum minimum dp by dr should be equal to 0. If you differentiate this, you end up with, I will write the answer directly. If you solve this, you end up with r is equal to r. So when R external becomes equal to the R internal resistance, we get maximum power in the external resistance. Remember the result. And look at the irony of the situation. Huh? If R and small r equal, means what? Both will produce equal power. So if your system produces 100 joules of energy, you can only use maximum 50. 50 will be wasted. And that is the best efficiency you can get. That is the worst part. That is the reason batteries are so inefficient. So if you store electricity into a battery and then you try to use it, while storing, you lose some energy. While using again, you lose energy. So if you're actually trying to store 100 joules of energy, end of the day, you recover only 30 to 35%. Batteries are highly inefficient to store energy. You lose while storing, you lose while getting it back. This is called maximum power transfer theorem. When the internal resistance becomes equal to the external resistance, you get the maximum power in the external resistance. Clear? You can differentiate that and equate it, you will get the answer.
So means even when the battery is not in use or it is joined with the circuit, it gets consumed.
Yeah. Kabhi nahi dekha? You keep the battery inside a a remote control or something, and after 1 month it stops working.
Yes.
Or if you ever buy a new watch or something, now observe what they do. They keep the battery inside, and here there's a small plastic sheet. Then make sure it is not connected to the circuit. If you just leave the circuit like that, battery will get discharged eventually. Okay, so that is about the heat produced and the everything. So next class, we are going to do instruments tomorrow on ammeter and voltmeter. That is more important one. So make sure to go through this. We have done almost 40 problems, 41 problems we have gone through. So make sure to revise this stuff. We have finished majority of the chapter. The next part is the more important one, instruments. That we will do tomorrow, ammeter, voltmeter, and we will do a lot of problems on that. So by Wednesday, we'll wrap up the chapter. So you have time. Getting it? So try to finish off capacitors, whatever, by Monday at least, and you have to start doing current electricity from Tuesday. Okay, so with this, we'll wrap up for the day. So any doubts, anything you can ask me, or else you're free to leave. So take care, stay safe. Tomorrow it's the class at 9 o'clock. I'll see you tomorrow at 9.